All right, there you go. I'm glad you're here, all you wonderful people. Let's go ahead and get started with today's lesson. Moving over to, okay, screen share. I don't know why it always moves it into a different place each time. Okay, so our objectives for today: solve inequalities, graph inequalities. Well, it should say graph inequalities. I don't know why it says graph inequalities. Oh well, maybe there wasn't enough inequalities. Write an interval notation. Solve and graph and and or problems, although we probably won't get to that today if I want to keep the video within this certain time period. So let's go ahead and move into the first part of what we've got going today. So we got to know which ones to use. So we use a closed circle. Sometimes I call these filled circles, like that. So we use a closed circle whenever we have a less than or equal to, or a greater than or equal to symbol. And closed means that it is included. It is part of the solution, and if we pick that exact number, it will work. Then we also have the open circle, which is this hollow circle. I called them hollow and filled circles for the longest time, but the material here is telling me that I should call them open circles. And we use those whenever we have a less than or greater than without an or equal to sign. And that's how we mark them on the graph. And this one's kind of an, well, I wouldn't say new, but it's a little bit confusing, I think, for some people, because it looks kind of like an ordered pair. But just remember, it's not an ordered pair. Usually it has an infinity symbol in there. So if there's an infinity symbol, then it's probably not a ordered pair, an ordered pair. So it's got to have parentheses that mean not included. So if you use an open circle on the graph, so in interval notation, it helps a lot to have the graph on there. Once you graph it, then it's going to be much easier to put it in interval notation. Brackets means that it is included, so it includes that number in its solution. Or if you look on the graph, it was a closed number, a closed dot. So you think of it like a door, you know, like if this is a closed door, right? And if you're a little bug and you land on that door, you're going to get stopped. You can land there. But if you're going to try to land on this one, it's open and you just go right through. Hopefully that's a little bit of an easier way to think about it. So let's go ahead and get some exercises just to get into the habit of seeing what different things can happen. So let's just graph some of these. So my first one is x is greater than or equal to 8. Okay, so to graph it, I'm going to go 6, 7, 8, 9, 10. Your graph must include the number that it is marked from. So I need to mark it at 8. So I have my number line, and again, just include the number you have. So next we need to choose which kind of circle that we need. In this case here, we are going to need a closed circle. So I'm going to mark it with a circle and fill it in like that. And there are different ways to do this. I've seen other teachers do it other ways, but this is the way I like it because it takes up less time, takes up less space. So I usually mark a little bit above it, like a little fence post, and I have to find out which way it's going. So think of it like a bit of game of hide and seek. X is a hidden number. The only thing I know is that it is greater than 8. So reading it left to right, x is greater than or equal to 8. So I need to decide which way should I go. I can go to the left or the right side of the road. Okay, so again, I'm looking for numbers greater than 8. So this means that I must be going this way. And that's probably one way, but the other way is to check it, all right? Check it, or you can just use this way to find out which way to go. So in this case, again, x is greater than or equal to 8. So if I put 10 in there, 10 is greater than or equal to 8. And that's true. This is a true statement. So since it's true, I know I'm headed in the right direction. Any number that I put in for x that is higher than or even 8 itself is also going to work. So let's try 8 itself. What if I have 8 is greater than 8? Is this true? Well, okay, the or equal to does make a difference. So in this case, 8 is greater than or equal to 8, and that is true also. So I can pick 8. Like I said, if you're a little bug and you're trying to land on that, you would land right there perfectly on it. But if I pick something on this side that is not underneath the arrow, so 6 is not under the arrow, and if I pick 6 in for x, 6 is greater than 8. That is not true. That is false. So there we go. We tested it 3 ways. We know that it is pointing in the right direction. And I know some teachers will teach shortcuts. Don't use any of those shortcuts. Or if you do, you should at least know how they work before you use them. Okay, so now interval notation. So to use interval notation, you're going to use your graph. Start from the left side and work your way to the right. Okay, work your way to the right. So left and right. Okay, there we go. We run into the solution right there. So in this case here, it is a closed circle. So I'm going to use the bracket, the square end bracket. Since it is included, we're going to put 8 in there. And we're going to continue on. So again, everything higher than 8 is a solution. So what is the largest number we could pick in and have it still work as a solution? That would be, well, infinity. Infinity is the largest number I can put in there. And it will still work. All right, so let's go ahead and try this one here. A has to be less than -1. So I'm going to include -1 somewhere in my number line. Doesn't have to always be in the middle, but it's a pretty good starting point. So from here, I'm going to mark out -1 because that's where my number begins. I'm going to use an open circle, the hollow circle, and that means I can't land on that. I cannot pick -1. This value for A has to be less than -1. So if I read it from left to right, so read your statement, A is less than, because it's facing away from, -1. So A is less than -1. And just by saying A is less than -1, again, it's a game of hide and seek. I know A is hiding this way, and I'm going to test it out. So testing it out, I get -3 and replace that with A. This should be a true statement because it's underneath the arrow. But in this case, I have 2 negatives. All right, sometimes that happens, especially in real life. You have 2 negative options. Let's say you're riding a bike and your bike breaks down and you fall off. All right, do you hit yourself in the head? Or do you, if you're flying forward, do you try to stop yourself with your arms? Chances are you're gonna, like that, make the decision to stop yourself with your arms. If your arm breaks, well, you're gonna be in a cast. But if your face breaks, or even worse, your brain, that's bad, right? So if you have 2 bad options, you go for the one that is less bad. Same is true with negatives. If you have 2 negatives, like 3 and 1, you go for the one that is further to the left. So all numbers this way, sorry, to the right, all numbers to the right are greater and all numbers to the left are less. Okay, that should be easy to remember. So if I look at 3 and I look at -1, it's further to the right. So it's closer to this G, so that means it's going to be greater than. Okay, now putting it in interval notation. So starting from, well, the lowest number we have is negative infinity. Because I just need this number to be less than -1, and negative infinity is less than -1. Going to the right, the highest number I can pick, well, I can't actually pick it, which is why I'm going to use a parenthesis, but mark it at -1. Yeah, there you go. Mark it at -1, and we're done with it. Now, if we check it the same way we check this one here, what would happen if I pick -1? -1 is A, so -1 is less than -1. Is that true or false? That's going to be a big false. Because -1 and -1 are equal, but there is no or equal to sign. So that or equal to sign does make a difference on whether this is going to be a true or false statement. And that's kind of the basics of graphing and interval notation. So to solve an inequality, you follow the exact same steps. So if you remember solving equations or algebraic equations, you do the exact same thing. If you want to solve for a letter, you got to move all the other numbers on that side away from that letter. You got to follow your directions, which I have right here. Take care of your parentheses or your grouping symbols is your first step. Number 2, combine the like terms on the same side. Number 3, pick a side for the variable and move the variable to that side and all the other numbers to the other side. Take care of your your addition, subtraction, multiplication, division. So same rules as equations. But there is one rule that you got to watch out for, and that is to switch the inequality sign if you multiply or divide by a negative number. If you multiply or divide using any negatives, right? So if you had a less than, it should be a greater than. If you had a greater than, you switch it to a less than. Or if it's any of the or equal to's as well. Now, I don't know if I have enough time to go into why that is. Let me see if I can do a really quick one. So let's say 7 is less than 10, which is true. Okay, no one's going to argue with that. 7 is less than 10. But what happens if I were to add 5 to both sides? So add 5 to both sides. 12 is less than 15. Still true. I can add numbers and it will still be true. What if I were to minus 20? So start from here, 12 less than 15 and minus 20 from both sides. Minus 20. And it is still true. I have 2 negative numbers, but it's the smaller negative number. Okay, so what if I were to take this and multiply it by -1? -7 is less than -10. Is that true? No, because if it's a negative, 10 is higher absolute value, or as I just say, bigger. 10 is bigger than 7, so this is false. So to make it true, I have to switch the sign. -7 greater than -10. Now this is true. So again, just remember that adding and subtracting does not change the statement. Okay, the inequality does not change direction if you add or subtract. Only when you multiply or divide by a negative, then you get to switch the sign. All right, so let's go ahead and practice some of these now. And it looks like we're going to have to use that on our very first problem here, because I am going to have to make a decision. I can either minus 7v from both sides, which is what I'm going to do, or I could add minus 5v from both sides, but that's going to make my v on this side. And neither side is right or wrong. In fact, both methods have their advantages. So what I'm going to do is every time I run into a problem like this, where I have a choice to either move the variable onto the left or the right, I am going to alternate the choice. So in this first one, I'm going to go ahead and use the rule that we just learned. And I'm going to move v over to the left side. Now that will make it negative 2v. All right, now I also have to move this 1 out of here. So I'm going to minus 1 here, minus 1 there. So again, same rules that you use for solving algebraic equations. I got to get rid of everything. So divide both sides by 2, but just not any ordinary 2. We got to divide it by negative 2. Cancel the 2, cancel the negative. So both of those get canceled. I also cancel this negative here, but be careful because right here, this is the step you have to pay attention to. Because in that step, I have to flip or switch the inequality. So v is now less than 9. So again, make sure you flip that sign, right? Whichever way it was going, you got to flip it now. Again, that's the only rule. Otherwise, everything is largely the same as algebra. If you know anything you do in algebra, you do it here also. Okay, so now we got to put 9 on the graph somewhere. And let's go ahead and mark it out. So mark it out. In this case, I'm going to need a hollow circle because there is no or equal to. And I need to mark out which direction it has to go. So again, if I read it, v is less than 9. So again, this v is hiding from me. And it's somewhere less than 9. So I got to pick which way to go to look for it. And if I read it, I think less than is over here. So 7, well, I'm going to use that to check it. So just imagine 7 is here for v. 7 is less than 9. That's true. 7 is lesser than 9. So we know this arrow is pointing in the right direction. And if we want to, we can try a false example. 11 is less than 9. That is false. 11 should be bigger than 9. Now I'm going to move into interval notation, which I cannot pick negative infinity, so I'm going to use a round bracket. I'm sorry, a round parenthesis. And go to the right. And the largest number is 9, but I can't pick 9 because of the open circle. I'm going to use a parenthesis again to say that it's not included, so I cannot include 9 in the solution set. But any number, as long as it's smaller than 9, is going to be true. All right. Now I like this assignment set because it always keeps you on your toes. It always pulls these little tricks every now and then. And this trick here is the one that I've been telling you to watch out for since we started algebra. If you have a negative outside of a parenthesis, in this case it's -3, you gotta flip the signs of everything in the parenthesis. Okay, no problem there. Combine your like terms. So I have an x term and another x term, so I'm gonna put those together. So 6x minus 27. In fact, you know what, I'm gonna go ahead and minus 27 from both sides here. So minus 27, I'm gonna write it really small. Minus 27 here. If I was thinking a little bit ahead, I could have given myself a little bit more space. Now I have to add 27, and that would be 34. Divide both sides by 6, and 34 does not divide by 6. So I'm going to divide it like this, and it's going to be, there's going to be a little bit of remainder left over, so we're going to turn it into a mixed number. Mixed numbers are a little bit easier to graph. I mean, you could use a calculator for this one too, but I think it's important to learn mixed numbers as well. So 6 fits into 34 5 times, but again, it doesn't fit in there nicely, so we're going to have to go with 30. and check for remainder here. So I have 4/6. Okay, and your remainder becomes the top number, and your bottom number is the number you originally divided with. So here I have 4/6, but I'm going to reduce it. So I'm going to go ahead and reduce this. X is greater than, I don't need to flip the sign because we didn't do anything to make it flip, 5 and 2/3. So I'm going to reduce my fraction. 4 and 6 are both even numbers, so I divided them both by 2. And that should be enough. That should be enough to graph it. So 3, 4, 5, 6, 7. So 5 and 2/3 is a little bit more than 5. Well, it's actually a little bit less than 6, but it's between 5 and 6. So to graph it, I'm going to take 3 and I'm going to divide this area between 5 and 6 into 3 equal segments. Doesn't have to be perfect. And 2/3, 5 and 2/3 is going to be this second one. The second one out of 3. So 1, 2, 3 out of, so 2 out of 3, so there's 3 segments. Now I got to determine which way this is going to go. Is it going to go left or is it going to go right? So again, read it. X is greater than, and you read it by which way the mouth is open. So if the mouth is open towards the number you just read, that's the greater number. So X greater than 5 and 2/3. So I need numbers greater than 5 and 2/3. But again, you can also just pick a number, like in this case, 7. 7 is greater than 5 and 2/3. That's true. So if it's true, that's the direction you got to go. And again, there are some shortcuts, and I know teachers teach this shortcut, but I'm going to tell you, don't use it. Don't use it unless you know what you're doing, because you can get the wrong answer. It's kind of like PEMDAS. You'll get the right answer most of the time, but there are going to be cases where they will purposefully trick you, and you will not be able to use that trick. All right, so interval notation. Since it's a filled circle, I'm going to use a bracket. Bracket. Square bracket. That means it's included. So if I pick 5 and 2/3, it's going to work. That is a solution. But if I pick any number higher than that, all the way to infinity, which I can't include infinity, because as soon as you get to infinity, you just add 1, and that's a bigger number. And you have a new infinity. So anything as long as it's greater than 5 will work out. Okay, so that's it for this one. Let's go ahead and move on to the next one. So hopefully you have your packet in front of you. That way you can follow along. I do have Schoology working, so I don't have it working. The school got it working. So it's like the 5th week of school, and they now finally got Schoology working. So if you have not received your packet yet, you can go to Schoology. I'll send you a link probably when this is over. I'm not done. I'm still working, just tying up a few things. But you'll hopefully by the end of today, you'll be able to download your assignments and start working on them in person. So that way you don't have to, wait for your packet anymore. So that's kind of a small announcement. Okay, back to the work. -2, so I have -2, so I got to distribute both of these. So not only do I double them, but I have to flip the sign. So 4 was positive, now it's negative. This is negative, now it's positive. So again, I like this because it has a lot of these small tricks that people always miss. Okay, I don't have any like terms, so now I got to pick a side for the P to go on. So I'm gonna move this off of this side because I want, if I can, I want this variable to stay positive. So it's not here. I want to stay positive and stay on the left. So if I -4, that's not enough to make it negative. But at the same time, I'm also going to get rid of this 52. So again, like I said, it's kind of like a trade where one side wants the variable and the other side wants the regular numbers. And it's usually the left side. Well, actually, no matter what, your variable should always end up on the left side. All right, so let's go ahead and see what we get in the next step. 12 minus 4 is 8p. Oh, and we flipped the sign because we minused, right? No. Okay. Let's see what the crowd has to say. Yes, this is the 5th week packet. So if you're following along, it's the one that says week 5, which I had it here just a minute ago, but actually I had to give it to a student, a new student that I just barely got. He enrolled yesterday or so, and I had to give him the packet. So it's somewhere. I have one that I filed away, but it's somewhere. Yeah, but we're on week 5. Anyway, so divide both sides by 8. Now I know that 60 divided by 8 doesn't quite fit. We're going to have a little bit of remainder, but 8 times 7 is 56, and 8 times 8 is 64, and 60 is directly in the middle between those two numbers, so that's going to be 7.5 or 7.5. Now this is negative, so I got to be careful with that. I made that mistake in one of my morning classes. I accidentally put everything was calculated right, but for some reason I just forgot to put the negative on there. Okay, you just got to be careful sometimes. Okay.
Mr. Ness?
Yeah?
I'm actually in Flag right now. I have an appointment and I'm going inside right now.
All right, well, thank you for being here.
Yeah.
Don't forget, you can always watch these later.
Okay.
Good luck.
Okay, thank you. Bye.
All right, now negative 7.5 is going to be on the left side of 7.5. I try not to point with my hands because I realize that the image I see is mirrored, and when I watch the videos, I notice that it's the right way. So I actually don't know which way I'm pointing sometimes. Now, is this the right way? Let's test it out. Let's try, because I know 0 is down the line. Is 0 less than negative 7.5? Now 0 is a good number to use to check because 0 is greater than negative numbers, but it is less than positive numbers. So when we tested it, 0 should be greater, so that's not that way. So again, check yourself really quick. Just look it over, check it. If it doesn't work, then you're just gonna have to reverse the direction. And then from here, we're just gonna have to put it into interval notation. So starting from the lowest number, wait a minute, or did I have it right before? Or did something happen? Oh, okay, I was joking. I see what happened. I was joking because I did say, well, when we minus, do we flip the sign? And then I got distracted and then I didn't flip it back. But when you minus, no, you don't change the sign. Okay, when you minus something, don't change the sign. Only when you multiply or divide. So in this case, I almost didn't catch that because I was thinking about, wait a minute, this doesn't quite work out. But yeah, it is this way. Almost my bad. Now, again, I did that to see who would catch it, but I didn't even catch it myself. All right, so going left to right, we have nothing, nothing, nothing. Okay, now we get to negative 7.5, which is not included. Open circle means we use a parenthesis. And it goes all the way to infinity. And again, we can't include infinity, so infinity is always a parenthesis, never a bracket. Ugh. All right, let's see. I haven't used blue in a while. Let's go ahead and move on to number 6. So make sure you distribute your negative. All right, because again, this one is always gonna make you remember that. So I gotta reverse the sign of both of these things on the inside. 5 minus 25. There we go. We got rid of our parenthesis. Let's go ahead and combine like terms. So 3 minus 1 is 2. Minus 4m is greater than 5m minus 25. Okay, now I have to pick a side for the variable to go on. Now, if you remember the last time, I made it into a negative, and then I had to use the rule to flip it. Now, this is not necessarily an easier or a faster way. It's the same amount of work. But there is one small advantage, and that is if I move this over to the right side, it stays positive. So I want you to imagine maybe a month from now. Okay, well, I don't know what's going to happen with this year, but you know, if you're on a test or a quiz and you're thinking to yourself, oh, shoot, I remember there was something I had to remember. What was it that I had to remember? Oh, the sign, right? Oh, shoot, what was the rules I do when I need to flip the sign? Well, here's one way that you can do it without remembering the rule, and that is what I call keep the variable positive. So I'm going to move it onto this side, which is the right side, which is not normally the side we put it on. But the good thing about this is that it will be positive 9. Now, I'm also going to have to add 25 to both sides so that I get 27. Now, the m is still on the wrong side, and I'm going to go ahead and show you what to do. So we keep solving, right? I got to get rid of this 9, so divide both sides by 9. And I get 3 is greater than m. Okay, so that shortcut trick I was talking about with graphing, I'm not going to go over what it is, because if you don't know what it is, I don't want to tell you, because it's probably better that you don't know it. But it goes something like this. You look at the way the thing is pointing, and if I go the direction that it's pointing, it should tell me that this way is the right solution. But if I check 5, 3 is greater than 5. It's not opening towards the bigger number. So that is not going to work. So I get people that do that. They tell me, oh, you look at that thing and you see which way it's pointing. That is false. It does not always work. Okay, and you know, a lot of people wouldn't do something if it, you know, they wouldn't buy something if it didn't have a chance of working. You know, I mean, like, how would you feel if, like, you went to a store, you know, like, let's say there was a really bad store and 1 out of every 10 items you buy didn't work? Would you shop there? Probably not. You'd buy a toaster, and then it'd be like, you'd go home and it wouldn't even make your bread warm.
It's called Walmart.
I don't know. Walmart's pretty good about taking returns, though. But anyway, we're not done yet. We still have one thing left to do, and that is to make the variable go first. So I'm gonna flip everything. Everything is gonna flip. So imagine like a mirror. I want the m to go first using reflexive property, which I've been using a lot in all of the lessons. But this one has one more small thing, and that is you've got to make sure the mouth is open towards the same number. It's open towards the 3, so when I flip it, it should still be open towards the 3. Now you can see that everything is flipped. And I didn't have to do the rule where I flip the sign if I use the negative. I still have to flip it. But it makes, I think this might make a little bit more sense. And like I said, if you have to remember this rule, or you know, maybe you're in a college entrance exam or something, and you don't catch this, you're probably gonna have to retake some math courses. So that's what this, that's the way this is used, is to just get the to find out which way it's pointing, because again, you do got to switch these signs. All right, so coming in from the negative, again, start from left to right, negative, and we get to 3, which 3 is included. We use a closed circle, so we're going to have to use a square bracket to show that it is included. So somebody reading this would say, okay, I can pick any number from negative infinity all the way to 3, with 3 being included. There you go. All right, I'm gonna, shoot, this thing's standing right in my way. Okay, there it goes. I'm gonna move it out. All right, now I'm gonna go ahead and do this one here. So I'm gonna use the distributive property, get rid of these parentheses. 3 times 8, so 8, 16, 24, so that's gonna be 24x minus, and then 3 times 9 is 27. Flip this, and 4 times 6 is going to be 24x plus 4. All right, double check it, make sure I got all this right. Okay, nothing seems off. But I'm going to move this 24. So let's get this 24 off of here. And okay, do you see it yet? We lost the 24x and this 24x also. So this is going to be one of those special cases that I was talking about. So the special case happens when you lose a variable, or I should say you lose all your variables. When you lose all your variables, it can be one of 2 things. Which of those is it? Well, let's keep going. All right, so negative 27 is still there. Greater than, it's greater than 4. And we ask ourselves, is it true or is it false?
False.
Yeah, that's false, because if you have a choice between a negative option, it's like, would you rather get $4 or would you rather get, I don't know, punched in the face? Okay, in that case, it's very obvious. You would always choose the positive option. So if it turns out to be false, you get no solution. There is nothing that we could substitute in for those x's that would make it work, that'll make it true. So that's it. That's all we can do with that one. All right, now let's go ahead and I'm going to distribute the 10 to both sides. A lot of distributing on these. 9 times 8 is 72. And this one doesn't have the negatives, so I don't need to change the sign. That's a lot easier. I mean, like everybody knows how to do those ones. All right, so 10 minus 13, so that's going to be negative 3a minus 30. Minus 13, okay, 3a, negative 39. Okay, make sure nothing's weird yet. And I run into that same kind of problem I had earlier. I can either add 3a to both sides, but if I do that, my a is going to be on the right side. And last time we did the whole flip thingy, so I'm going to go ahead and use the rule method. And I'm going to minus 9a from both sides. It's going to be a negative. All right, we are going to have a negative. But again, if we remember the rule, it shouldn't be that big of a deal. Now, if you want to pick one of these methods to stick with, you know, be my guest. It works. Both of them work. Which one is easier for you? Nobody can decide except for you. All right, negative 12a, and this would be negative 42. And I'm going to have to divide both sides by -12. And there it goes again. You got to be careful. You know, when you divide by a negative, that's the thing you got to worry about. All right, exclamation mark here. When you divide by a negative, that means you're going to have to flip the sign. So A, and 42 divided by 12 is 3.5. And you could easily just, you know, divide that yourself, or however, use a calculator or use the division bracket. So 1, 2, 3, 4, 5, time to graph it. So 3.5, if I ask you where 3.5 is, you could all probably point it out without even thinking about it. But again, you got to know which dot to use. We need the closed circle. And now we have to decide which way it's going to go. Or I shouldn't say decide, we should find out which way it's going to go. So again, if we read it, A is greater than or equal to 3.5, it should go this way, because this way is the numbers greater than. Now, if I pick 5, like if I said $5 is greater than $3.50, that's true. $3.50 is less than $5. You know, if I had a hand with $3.50 and a $5 in one bill, and I said to take one, you'd probably pick the $5. All right, now we just got to put it into notation, interval notation. So from negative infinity, we have nothing. And I said nothing. All right, 3.5 is the lowest. And now we get to 3.5, which in this case, we're going to use a bracket because it is included. It has the or equal to. And this goes to positive infinity. All right, looks fine to me. I guess one other thing you could do is on this one, you could put a slash circle there. And that means, it means empty set, or it can also mean null set. Now, at the college level, I also teach some of the higher level maths. And a lot of people surprisingly don't know that the difference between empty set and 0. So a lot of people use it as 0. And earlier today, I was at the glass shop here, and they actually used that instead of 0. So I'm like, they definitely don't know that it's not the same thing. Now, some people, they do that because they want to, you know, if you see something that looks like a 0, they want to make sure that you know the difference, that it's 0 and not like O, especially if you're typing something like an email address or something like that. But it's just one of those small things that if you're not really a math person, you don't even notice it. But yeah, that 0 slash means absolutely nothing. Like nothing goes in there at all. There is nothing in there. You know, like if I told you there's a room behind me and it's got nothing in it, your imagination would probably say there's no furniture or anything like that in this room. But if I put this symbol, it could imply there's nothing in there, as in there is no oxygen in that room. In fact, you open the door and it's just a corner of space where there's nothing at all. So that's the difference between those two things. It's not a big deal. Don't worry about it. Let's go ahead and add these up together. So with this one here, I get 8 minus 21, which is 13? Negative 13? Negative 13. I guess that's what it is. 14r is less than 3r minus 30. Now I got to pick a side for the r to go on. Now the last time I did this, what did I do the last time? Did I flip it? Oh yeah, no. Okay, I used the rule. I used the rule to flip it, flip this thing by dividing by a negative. So I'm gonna do the other thing. Like I said, I'm gonna switch between the two in alternating methods. So I'm gonna add 14r to both sides. And again, it moves the r to the right side. I just gotta remember to flip it so it's back on the other side once I'm done. So I canceled this one. So that means I gotta cancel this one. And that this allows me to cancel some of these. So in this case here, I get 13 minus 30, which is gonna be 17. 3 plus 14 is 17. All right, but we still got to keep going. Divide both sides by 17, divide by 17, cancel, cancel. And I got nothing left. So I get 1 is less than or equal to r. But let's flip it, all right? Turn everything over. But especially pay attention to which way the mouth is open. It's open towards the r. So when I flip it, r should still be the, it should still be open towards the r. Now I got a lot of writing in this one, and I don't think I've been boxing my answers. I know I do that with all the other assignments, but for some reason I just seem to have forgotten to do that with this one here. So I'm gonna go ahead and put in my numbers for my graph. And r again is, well, use a closed circle, the filled circle. And I got to find out which way is it going to go. So r is greater than 1. So let's try 3. Plug in 3. 3 is greater than 1. Or the mouth is open towards the bigger number, so that is true. So we know we have to go this way. Once we have the graph, we use that to do the interval notation again. So coming in from this side, we have nothing. And we have 1. So 1 is the number, and it's included. So we use the square bracket. And it goes all the way to infinity. But we can't include infinity, so we're going to use a rounded thing here. Okay, looks like we're doing pretty good on time. I haven't even been keeping track of time, actually. I just sort of gotten lost in this. -3 times 8, so that would be 8 times 3 is 8, 16, 24. Okay, I don't know why, but for some reason I just felt, I had a weird feeling about that one. And again, the negative has to change both of these, so they're both going to be negative. 4 times 6 is 12, 24, so 24. All right, now I got to move p. Look at the p. I can either add 8p to both sides or add 6p to both sides. If I add 8p to both sides, that's going to put it on the left side, and it's going to make it negative. Sorry, keep it positive, which is what I want. I'd rather keep it positive. And in the meanwhile, I'm going to add 24 because I want to cancel it here. And, oh, wait a minute. If I add 24 to this side also, it also cancels. Does that mean we have no solution? Okay, now be careful with these special cases because I can see that this one might be confused with a special case. 8 minus 6 is going to be 2p. And since there's nothing left on this side, we put 0 in there. We still have the variable. The variable didn't disappear, it's still there. So this problem does have a solution. Divide both sides by 2 and p is less than 0. So 0 divided by 2 would just be 0. P is less than 0, so if I put 0 in here, mark it and find out which way it's supposed to go. So P is less than 0. So if P is less than 0, I got to go this way. And if I check a number like -2 is less than 0, that works out. Starting from the negative, I'm again always going to the right. Again, I'm not sure which way I'm pointing, but I think it's this way here. So go to the right. And coming from -infinity, I'm going to reach 0. And 0 is not included, so I'm going to have to use a parenthesis. And there we go. Last exercises, I think. All right, last page. And we've got one more page after this, but this is the last one with major exercises on it. So let's go ahead and do this one. I'm gonna use blue. I haven't used blue in a while. 11x minus 4. 6x minus 3, and I got to multiply both of these, so -3 and 5x. I said 5x. I was looking at that. How did I put 15 in there? Or did I say 15? Anyway, 11x minus 4. Oh, 6 plus 5 would be 11 minus 3. And make that x a little bit more x-like. Okay, now I got to move this 11 out of here. So I'm going to minus 11x minus 11x. And it looks like we ran into a special case. So what is this going to be? No solution? Now, when we hit the no solution problem, I said, hold on a minute, there are two cases that it could be. You've got to check it first. Is it true or is it false? So we lost the x numbers. So let's look at the regular numbers now. All right, that's a terrible one. Let me redo that. There you go. So is this true or is it false? -4 is less than -3.
It's true.
There you go, it's true. So like, would you rather pay somebody $4 for something, or would you rather pay for that exact same thing with $3? It makes more sense to pay with $3 because if you go to, like, so let's say there's two different stores and, you know, one is selling something you really want, like you really want the cherry Dr. Pepsi, right? If one of them is $4 and the other is $3, you're going to go with the cheaper option. Or the thing that usually is like this is gas. Every gas station usually shows that they have, you know, their prices of gas. And your parents are probably like this. They'll probably say, like, one sign might say 265 and the other will say 280, and they're immediately going to drive to the 265 one. You know, even if it's like 3 cents difference, they're going to go to the one that they have there, right? Because if you're getting the same thing, but actually I don't believe gas is the same thing. I always buy Chevron even though it's more. So all real numbers. And this is something I learned when I used to drive to Tucson all the time. I used to go to school in Tucson. So I used to drive back and forth to Tuba to Tucson. And I used to buy this really cheap gas. I don't remember exactly what the gas was, but like right around the corner from my apartment, there used to, I think it was Safeway gas. So I filled up the tank on Safeway gas and I'd go try to drive back to Tuba and I'd burn through it. And I'd be like, whoa, you know, I used up all the gas before I even got there. But then when I go to Chevron, when I used to go to Chevron, I noticed that the gas would get me much further before I had to gas up. So I think a lot of people don't really think about that. They think all gas is the same, but I kind of don't believe that. And again, it's only because I had to drive back and forth a lot that I realized that it is not the same thing. Well, at least that's my belief. I don't know. Maybe I'm doing something like laying on the gas more or something. Anyway, so if it's all real numbers, that means everything from negative infinity to positive infinity. Everything is a solution. Anything you can think of is always going to make it true. No matter what I put in there, once I evaluate it, that mouth is always going to open towards the bigger number. Okay, so there you go. I guess that's another life lesson that you could have learned there, is that I personally don't think that gas is the same thing. I think some gases also burn cleaner than others, which I know most people don't care about the environment, but you know, your engine life lasts a bit longer. And I think for a lot of people, they know that certain things burn cleaner than others, like, I don't know, oil lamps, and certain woods will burn cleaner with less smoke, the kind that grandma uses. But then when you go camping and you use the camping firewood, you get all the smoke in your campfire, right? So it's kind of like that. I just sort of think it's like that. Okay, so -2 is dividing, so I'm going to times both sides by -2, and that cancels that out. So let me go ahead and just evaluate this. 4 times 10w minus 5 times 10, so that'd be 50. Just double check that. And then I'm gonna have to use distributive property here. Even though it's backwards, still gotta do that. Okay. Combine your like terms. So let's see, I have regular number here, so that's 10w minus, and 4, because my minus is a lot bigger, so it's going to be 46 less than 2w minus 14. There you go. Combined all the like terms on both sides. Now I need to pick a side for the w to go on. Which this is going to be a pretty straightforward choice, because if I plus 2w to both sides, it's gone from this side, and it stays positive, and it goes to the left, which is the side I want it to be on. All right, and then go ahead and add, combine, so 10 and 12, I'm sorry, 10 and 2 is 12. 12w less than, and here I'm gonna get 32. 6 minus 4 is 2, 4 minus 1 is 3. Okay, yeah, that works. Divide both sides by 12. And 32 divided by 12. Wait a minute. It's going to go in there 2 times, I think. And that's going to be 24. 32, and that's going to be 8. So 8 is my top number, 12 is my bottom number. But if I simplify that, I get w less than 2 and 4/3. Now, when I did that this morning, I was like, is it really, I had to go check all of them, and I'm like, are they all really, I said 2/3. Are they really all 2/3? And I checked it, yeah, they are. It's anyway, let's go ahead and, how do I include 2? So I'm gonna put 2 in the middle, 3, 4, and then I'm gonna fill it this way. So 2/3, as we know, again, divide it into 3 equal spaces, and it's gonna be the second of those. W is less, so that means I'm gonna have to go this way or check it. So let's put 0 in there. 0 is less than 2 and 2/3, so that's true. And it goes all the way from negative infinity, and the highest number is 3, but I can't pick 3. If I pick 3, it's, 2 and 2/3 itself. I'm probably getting in a hurry, that's why. I'm anticipating the end of the lesson. 2 2/3, there you go. Okay, last part of this is, oops, wrong one, a set builder notation. So we usually put something like this where x is greater than 5. If you're gonna do any sort of advanced math, this time I'm not gonna be too big on this. If you want to do set builder notation, go ahead. But you would just put x greater than 5, but just put another x in front of it, so you get this x/x sort of thing. And that just means any x such that x is greater than 5. So basically, it just means anything works as long as it's greater than 5. Because remember, there's not just one solution. When you're solving algebraic equations, you get one solution. There's usually just one thing that will work. Sometimes 2 or 3, depending on the power of your equation, or if it's an absolute value or a radical. But in these things, in inequalities, you will always get more than one possible answer. You will get a multitude. You'll have many of them, right? It can, anything as long as it's greater than 5. So I could pick like 4 billion and that will still work out. So anyway, I think that's it for us today. I'm not sure what else we have. So if you have any more questions or anything else, you can go ahead and stop by and ask. If